Okay, so what we would do with these to simplify this fraction, this rational expression, we need to try to factor. Okay, you can't just cancel out the 2x squared because they're going at the top and bottom, and the 5x because they're going at the top and bottom. Okay, you got to factor first. If this was times in here, then I could cancel those and divide 3 into negative 12, and the answer would be negative 4. If that was multiplication, I could do that. But it's not. So I have to factor. So I go, no GCF in either one. It's got 3 terms, and these are not both positive perfect squares, so it's not that special trinomial. They're both regular trinomials. So we multiply 2 times negative 12 and 2 times 3. All right, well, 2 times 3 are the ones that's going to work, right? Because when I add them, what do I get? 5, thanks. Okay, for 24, what do I got to multiply to get negative 5 when I add them? Multiply to get negative 24, add to get negative 5. Negative 8 and positive 3. Okay? So the numerator, I'll go out here and rewrite it. 2x squared minus 8x plus 3x minus 12. And again, if you put plus 3x minus 8x, that's okay. Right? That is okay. Not wrong. Then we group it. First two, last two. GCF is 2x. 2x squared divided by 2x is 1x. Negative 8x divided by 2x is negative 4. 3 is common. 3x divided by 3 is x, and negative 12 divided by 3 is negative 4. So the numerator is x minus 4 and 2x plus 3. All right. The bottom, the denominator, do it in blue. We're going to write 2x squared plus 2x plus 3x plus 3. Again, if you wrote plus 3x plus 2x, it still will work. Okay. Group the first two, last two. Both of these, we didn't have to worry about a negative sign in front here to put inside the group. 2x is common to this group. And 2x squared divided by 2x is 1x. And 2x divided by 2x is 1. We need 2 terms in there. 3 is common. And 3x divided by 3 is 1x. And 3 divided by 3 is 1. Got the same thing. That's good. So we got x plus 1 and 2x plus 3. Now I see a 2x plus 3 in the top and the bottom. So I can cancel. And that's my solution, my simplified fraction. So it looks like this. When we're done, looks a lot nicer, a little bit simpler, right? Questions on that? That's the type of things we were doing yesterday. That we were doing on homework. Then you also multiplied some fractions and divided. This one was the last one was division. All right, so number 3 is x minus 3 over x minus 2. Number 6 is y squared plus 3y plus 9 over negative 1 times the quantity y minus 8. You have to pull out a negative 1 from the bottom there. The top was one of those difference of cubes. Number 9, group the top, and once you factor both and then cancel, you get 4y squared plus 7 in the top, and then you had to factor out a negative 1 in the bottom, and then you get negative 1 times the quantity y plus 7. Anybody would need me to go over 3, 6, or 9? I think I got 6 on here. Yeah, there's 6. So there's the difference of cubes. Cube root of both, y minus 3, that's your binomial. Then you take the y and square it, for the y squared. For the middle, you go y times 3, so I get 3y. This sign is addition because that was subtraction. If this was addition, that would be subtraction. Those are always opposite. And then the 9 came from taking the 3 and squaring it. Okay? Then the bottom, we took out the negative 1, and y, negative y squared divided by negative 1 is positive y squared. Positive 11 divided by negative 1 is negative 11. Negative 24 divided by negative 5. So those change. And then it's y minus 3 and y minus 8. Don't forget the negative 1 is still part of that factoring. The y minus 3 is canceled. And then you get this in the top. Don't forget the negative 1 and the y minus 8 in the bottom. That was 6. All right, number 12 is right here. This is easier because there's no pluses and minuses in this. So there's no factoring you have to do. It's already factored. So the first thing I did was cancel 5 into 5 and got a 1, and 5 into 25 and got a 5. Then I divided 3 into 15 and got this 5, and 3 into 12 and got that 4. Well, then I saw I still had a 5 up top and a 5 in the bottom, so I divided 5 into both of those and got 1. So I got 4 times 1 for the 4, and 1 times 1 for the 1 for my coefficients. Then for the variables, I just count and see where the higher number is for each variable. I got 4 x's up top. There's no x's on the bottom, so they just x to the 4th up top. For the y's, I got a 1y here and 2 y's here. So this 1y cancels one of these and leaves me 1 left over in the bottom. Same thing for the z's. I got 4 z's in the bottom and 3 in the top. So all 3 of these cancel 3 of these. There's still 1 z left in the bottom. So that's an easier one because you didn't have to factor. It's already basically factored. You just start canceling. Okay, so look at the difference. Minuses and pluses, you got to factor first before you cancel. No minus or pluses, you can just start canceling. Figure out what they have common and divide those out. For the variables, I just count to see how many there are, and then the higher number, that letter stays wherever. Higher number in the top, it stays in the top. Basically just subtract. Let's go 4. 4 minus 3 leaves you 1z in the bottom. 2 minus 1 leaves you 1y in the bottom. Okay. Number 15 was x times the quantity, 3x plus 7, over 2x plus 3. Number 18, everything canceled out once you factored it. If everything cancels out, it's not 0. The answer is 1. So that was 1. And then 21, remember to flip the second fraction, do it, multiply by its reciprocal. When you factor everything, all the factors in the top then cancel out, so you have a 1 up top. And then everything cancels but one factor, which was a minus 8 in the bottom. So 1 over a minus 8 for number 21. Anybody need to see 15, 18, or 21? Good? All right, so today, day 2 of this, rational expressions. Okay, adding and subtracting. All right, adding and subtracting rational expressions is similar to adding and subtracting fractions. That's what rational expressions are, fractions. To add or subtract rational expressions with like denominators, just add or subtract the numerators and use the same denominator. You guys do this. 1/5 plus 3/5 is 4/5. 6/7 minus 4/7 is 2/7. Once you have a common denominator, then you can add or subtract. That denominator doesn't change. It's like 1 apple plus 3 apples, you got 4 apples. You don't change the name of the apples, right? They become double apples or something, right? So, same idea. Just like 1x plus 3x is 4x, not 4x squared, right? Now multiplying, we're just adding. But in order to add or subtract fractions, you've got to have a common denominator. So, can I add those? Yeah, common denominator, right? So in my answer, what's the denominator? X plus 4, it doesn't change. So just go x plus x, which is 2x. Negative 3 plus negative 2, negative 5, right? That's all you gotta do. So those are easy if you already have a common denominator. All right? What about this one? What's my numerator? What's 3x minus 6x? Negative 3x. What's negative 4 minus 1? Minus 5. Now, after you add or subtract, you should check to see if you could simplify your fraction, just like we did last night. Okay? With these two examples, we couldn't factor, we could factor a negative 1 out, but I'm just going to have a 3x plus 5. There's nothing here that I can factor, nothing I can cancel. Okay, so we're done, both of those, because I couldn't factor and reduce it all. But you should always check that. All right, when you don't have common denominators to start, you got to turn them into two fractions with a common denominator. Okay? So this is the part that people get confused with. Okay, so pay attention, please. All right? So we got to get a least common denominator, which is the same as finding the least common multiple. Okay? Those are the same thing. Okay, so that what you're supposed to do is factor each polynomial completely. Just the denominator, though. Okay? We're just worried about denominators right now. Do not factor any numerators until after you add or subtract. That's important. If you don't, you just go back to where you started. And you start seeing stuff that, I could factor that. And that's good that you're looking to factor, but not numerators in this type of problem. Okay? Just denominators to start so you can figure out the common denominator. All right? So it says factor completely. We're talking about denominators. Write any repeated factors as powers. So what they're saying is if I factor this, it's going to be x and then x plus 3 times x plus 3. Since there's two of them, they said use exponents for it. Okay? It says list the different factors. So what I always say, write down whatever factor you see in the bottom. So if it shows up in the bottom, you write it down. A lot of kids think, I'm looking for least common denominator. It has to be common to both before I write it down. No. If it shows up on the left side but doesn't show up on the right side, you still write it down. If it shows up, write it down. Okay? Then if you have common things, like if you had an x plus 3 to the second and an x plus 3 to the fourth, you use the x plus 3 to the fourth, the higher exponent, if that would happen. But I don't think that ever happens on any of our problems. Okay, so what I'm doing here is I'm turning this into a problem. I'm going to turn it into an addition problem. Let's change the color. So these are the denominators we're thinking about. And we'll just make this 3x and this x plus 4, let's say. Okay? So, what we're supposed to do first, not worry about numerators, just look at denominators. Factor them. Okay, so they factor them for us. The factors of negative 3 that add up to negative 2 are negative 3 and positive 1. The factors of negative 6 that add up to negative 1 are negative 3 and a positive 2. Okay? They already did the factoring for us. Okay, so for my common denominator, whatever I see, whatever shows up, I write down. So I got to write down an x minus 3. I got to write down an x plus 1. There's another x minus 3. Do I need to write it again? No. Then an x plus 2 showed up. So my least common denominator, or they're calling it a least common multiple of those two polynomials, is those three factors. Okay? So here's what you do to finish this problem up. All right, so there's our problem. So we're going to rewrite the two fractions with our common denominators so I can add them. So I have to rewrite this fraction with that denominator, and then I rewrite this fraction with the same denominator. Okay, that's what we're doing. That's the next step. All right, so look at the original. Here's the original denominator. Okay? There's the original denominator, right? What did I do to it to get the common denominator? I multiplied by x plus 2, right? So what do I got to do to the 3x? Multiply it by x plus 2. The same thing. You guys understand that? So the old numerator, you got to multiply by whatever you multiply the old denominator by. Okay? Whatever you do the bottom, you got to do the top, basically, is what I'm saying. Okay? Okay, here's the original denominator, which is those two, right? So what do I got to multiply x plus 4 by? The x plus 1. Whatever I multiplied the old denominator by, I got to multiply the old numerator by. You understand the procedure? Okay, then what I would do to finish this up, now it looks like this, I would do the addition. After I do what? What do I got to do before I can add these? What's this mean here? There's no symbol between them. Multiply. What's that mean? Multiply. So I can do multiplication before addition, right? Aunt Sally says to do that, right? So we still got to follow Aunt Sally's rules. So I've got a 3x squared plus 6x plus x squared plus 1x plus 4x plus 4. You follow what I'm doing? Am I making sense? Any questions? Now I'm going to combine like terms to finish it up. So I got a 3x squared and a 1x squared. I got 6x, 7x, 11x, and then the 4. And then what I would try to do at this point, now that I got it done as far as addition, I try to simplify this if possible, like we did last night. Okay, I would multiply 4 times 4, 16. Now there are factors of 16 that add up to 11. You got 4 and 4, 8 and 2, 1 and 16. Any of those add up to 11? No, so we'd be done. But if I could factor this, I would, because I might get one of these factors up here that I could cancel. Does that make sense, the procedure? Yeah. Okay? That's what we're doing. You have to do this work before, get this common denominator, multiply what you need to multiply, then add or subtract. Once you get it to a single fraction, then you try to factor the numerator. So don't do any factoring of numerators till you get there. All right, this next slide, there's no questions. This next slide is just showing you what I just showed you, but using old fractions. Okay? 6 factored into 2 times 3, 10 factored into 2 times 5. So you write down what shows up. Well, a 2 showed up, a 3 showed up, and a 5 showed up. You don't have to write the 2 again. And 2 times 3 is 6 times 5 is 30. That's where that came from. Okay? Hey, Liam. How are you? I'm good. How are you? We missed you. So, again, we had 2 times 3 For the 6, we multiplied by 5, so we multiplied the top, the 2 by 5. 2 times 5, that's where the 10 came from. Here we had 2 times 5, so we had to multiply by 3 to get to 30. My voice is finally changing. And then 3 times 3 is 9, so that's where the 9 came from. Then add 10 and 9, 19 30. So it's the same procedure that we just did. You guys understand this, right? You've done that years ago, right? Well, we're doing, it's just the same thing with the polynomials. Okay? Questions? Making sense? If it makes sense to you, that's good. If it's not, we'll just, hopefully through practice, it'll make better sense. If it's still giving you problems, ask. Okay? All right, so they factored for us. So what's my common denominator? X plus 4 and x minus 1. Do I have to write it a second, x plus 4? No. Whatever shows up, you write down. You don't have to write it down more than once. Okay? So I'm going to have to multiply this by what? To get it to look like this. X minus 1. So what do I multiply 2x by? Same thing, right? So that's what they did here. So the 2x, we got to distribute 2x squared minus 2x. Do that multiplication, and then add and subtract your like term. So there's only the 2x squared, that's the only thing with x squared. And then these are like terms. The x and the minus 2x gives you the negative 1x. And there's the minus 3. Okay? Then what are we supposed to do at this point? Try to do what? Simplify. I'll factor it real quick for you. 2x times x, negative 3, and a positive 1. Was it freezing up on me? Okay, there we go. Just won't do there. Anyway, that's a plus 1 there. Okay, maybe if I change color, it'll do it. It's not, something's going on there. But nothing's exactly the same, right? This is an x plus 1, that's an x minus 1. I can't cancel that. Okay, so that's basically our answer. All right? Okay, you good with adding and subtracting? All right, the other thing is they call these complex fractions. Fractions. They look like they're complex, look like they're hard, but they're not. All right? So the bar in a fraction represents division, therefore you can rewrite a complex fraction as a division problem and then simplify. Okay? So think of this problem as x plus 2 over 1 divided by 3 over x. What did we learn yesterday if we were dividing two fractions? Reciprocal. And what? Change it from division to division again. Good. So what we're going to do is make that times x over 3. Is there anything we can factor or cancel? No. So we just write x times x plus 2 over 1 times 3. So this turns into that. Over here, fraction divided by fraction, so multiply by the reciprocal. So flip that bottom one, make it multiplication. Now, is there anything we can factor or cancel? The x's. Which x's? The one with the plus 3 and plus 4 or the x and the 7x? Right, good. Because that's multiplication, right? It's okay then. Like that number 12, right? It was all multiplication, we could cancel that stuff. But since this was addition, we couldn't. Those were both x plus 3s or both x plus 4s, then we could cancel. So this answer would be 7 times x plus 3 over 1 times x plus 4, which is x plus 3. Those two make sense? For this first one, it didn't look like a fraction, so just put it over 1 to make it look like a fraction and multiply by the reciprocal. These are already fractions, so just multiply by the reciprocal. This one's a little bit different. All right? So we got 1 plus 1 over x over 4x plus 5, and we can write that over 1 to make it a fraction. So what do I got to do first? Add, right? Well, how do I add 1 plus 1 over x? Make it look like that, right? What's my common denominator? We'll go left here. What's the common denominator going to be? What shows up? If it shows up, what did I tell you to do? Write it down. Right? So I see a 1 in the next. Do I really need to put the 1? No. But if it shows up, you write it down. Because I can't factor. So, what did I do to this original to get this? Multiply by x. So I got a 1x up there. What did I do to this original to get that? Multiply by 1. What's 1 times 1? Okay? What's that? 1x plus 1, right? Or just x plus 1. So that's what it looks like. Now it looks like these two, right? So what am I going to do to finish it up? Flip this bottom one, multiply, right? You guys could finish it, right? Does that make sense? That's how you do those. Okay? So they're called complex fractions, but they're really not that complex. They look kind of that, but they're not. All right, so what have I told you about homework and its relationship to practice quiz and quiz? Harder, right? So you're going to see a couple tough ones for homework. As long as you understand the procedure, you'll be fine. So just try them all. Show your work. Don't find the answers somewhere else and write them down. There's another one that's already done for you. All right? Again, as long as you're trying them and showing me that you're trying, doing your own work, some of you are geniuses. And look at the problem and tell me the answer. Have you guys start teaching instead of me, so I can learn your way of doing it. Liam, did you do your homework?
No.
Okay. Yes, sir. Oh. All right. So Carter was teaching, like copying off of me, and he's doing it, and then saying it's submitting. I haven't done it. All right, thanks. I'll fix that for you. Sometimes kids are having trouble submitting, or it submits as a blank, because when you name it, if you name it yourself, or sometimes it names the PDF automatically, if there is a space in the name, it'll submit as a blank piece of paper. Okay? So check the name before you hit submit. If it's got a space in it, just get rid of the space and it'll be fine and I'll be able to see it. Okay? You guys have been doing a good job though. Let's keep up the good work. Stop share.